So a little over a year ago, I uploaded this video showcasing drone image and video segmentation in Python using OpenCV and using it for doing basically NDVI, Normalised Differential Vegetation Indexing on near-infrared photos and videos captured using my modified drone. So the purpose of this was to see that it would be possible to, instead of doing NDVI on an entire image or video, to do it on only portions of the pixels basically in the video or image. And these pixels would be thresholded, they would be the red reflected parts of the image, and on these parts we would do the NDVI. And this is a very interesting and useful way to do remote sensing to basically do feature detection of a landscape and detect, in this case, the vegetation, the potential health variable of, say, for instance, trees, grass, or whatever plant vegetation you want to monitor in the image. And so from this urban or let's say coastal scene, I was able to generate segmented maps, if you will, that show the NDVI with a bar here. And so following on from that, I wanted to do feature detection with using near-infrared photos for other things beyond vegetation. And this code, which is the video that I uploaded in October 2020, used primarily a fairly simple threshold value, which is basically low red and high red, and this essentially threshold image I was able to then use as a mask, and using bitwise and of this mask value I was able to essentially segment a near-infrared image with the red values. And bitwise and, if you remember from learning about logic gates, an AND operation essentially is a multiplier of of two bits in a let's say a string a bitwise string of numbers. So if we have, say for instance, a 1 and is in our NIR pixels and a 0 in our mask, then a 1 multiplied by 0 is 0. And if we have a 1 in our NIR and a 1 in our mask, 1 multiplied by 1 is 1. So that's essentially the bitwise AND operation. So it effectively is a marker of features that are already there, that are features of interest that we've defined as our interest features. In this case, are low red color, let's say, in between low red and high red in these videos or images, whatever. I'm being primarily images which I'm analyzing. So that's bitwise and. But what if, say for instance, I wanted to highlight features of interest which are not the highest, let's say near infrared values, which are the lowest. In other words, looking for stressors, looking for features in a image, in a video, which might indicate in the near infrared that the vegetation is under stress. And that for that I would use do the opposite. Essentially I would use bitwise not. So bitwise and is a multiplier, but bitwise not would be, if you like, it would be the inverse. It would be a mirror image. So if we had a 1 value, a high value, let's say, of near infrared, then if we use the bitwise not and our red mask, it would then give a 0. But if we had a 0 value or a low value of our near infrared, it would give a 1 as a value using not. So that's what I did in this research, which is looking for essentially stress caused by tombs or cairns in an image, basically by ruins, archaeological artifacts which may be buried partially or totally under the ground, under the soil, underneath vegetation. And so this would cause a stress to the growth of the vegetation. It would cause some type of stressor, which would then cause the near NDVI and subsequently the near infrared reflectance to be lower. And so if the stress is causing the near infrared reflectance to be lower, then I want that to be effectively highlighted, if you like, using Bitwise NOT in order to detect signs, if you like, of that archaeological artifact in the first place. So this I have shared here in my drone archaeology GitHub repository, and essentially showing what I mean. If I use Bitwise NOT on my threshold, I can then highlight regions, as I said, that are causing stress in the near infrared reflectance of vegetation. And these the cause of the stress in this case would be the tombs or cairns or archaeological ruins buried or submerged under the soil that are somehow interfering with the plant's growth and therefore their ability to reflect the near infrared. Because it turns out that healthy plants will reflect strong in the near infrared. Unhealthy plants will not reflect strong in the near infrared. So therefore, if we assume that the tombs may cause the plants to become unhealthy due to stress, causing added stress, and limiting access to water, limiting perhaps access to soil nutrients and so forth, then we can assume that the low areas of near infrared reflectance will have maybe perhaps something buried under the soil, or at least maybe have signs of disturbance. So an image that I can test with this is the image that I've taken here in a place called Loch Crew, and like many of these fields in Ireland, there's lots of tombs, ancient tombs buried under the ground, and there's different indications of them being given. Now, some of them are partially submerged, some of them are totally submerged, and this gives a nice kind of test case in order to test this technique. So this was taken in the near infrared. You can see here the tomb is partially submerged, and so this will be highlighted using the Bitwise NOT procedure on our threshold mask. So this is all done in Python and can be implemented quite easily from the console here. So I'll give it a try and we'll see. So this is the Bitwise NOT highlighting the values of the near infrared, and it should then output a image that will be not only the image of the near infrared, but actually I've also included contours that actually highlight the let's say the perimeter of the region of interest. The region of interest being again the values of low near infrared reflectance. And so if with this operation I can then add the contour, I should be able to generate a map of sorts. Can't really see it here, but I'll show you on the folder of, yeah, so that's our near infrared region being highlighted here. You can see it in the console. So the tomb basically is being highlighted in near infrared, in NDVI, I mean, because it was detected in near infrared, and doing NDVI and doing Bitwise NOT allows me to basically isolate the tomb from what is effectively the background image, and on this tomb I'm able to then overlay a contour on the region of interest. This code has two folders, test images and test photos. The test images will have our segmented NDVI, but the region of interest will be our tomb. You can see here the tomb is then being isolated. The NDVI value is in more or less around 0. The background then is even is relatively higher, but because this is bitwise NOT, basically the low values become high and the high values become low. Okay, so, and our contour that I've overlaid overlays the perimeter surrounding the tombs. Okay, so the regions around the tombs have the contour drawn around them because they are the regions which show up the brightest in the image, in the processed image, due to the bitwise NOT operation. Okay, so this is a way in which we can use remote sensing, near-infrared remote sensing, in combination with the bitwise NOT operation, and simply overlaying a contour on the NDVI value output from this bitwise NOT operation allows us to do, if you like, a type of passive feature detection of these images. So that's just a quick summary, if you like, of this technique that I've come up with for doing essentially remote sensing, not in this case not of vegetation, but of essentially man-made objects, ancient objects, which are buried in, if you like, in a mixture with vegetation. Okay, so bitwise and, in summary, is very useful for highlighting the vegetation in the image, but bitwise NOT is very useful for highlighting the man-made structures that are causing stresses to the vegetation in the image. Okay, so this can also be done on video. So I also have made a video of essentially tracking this time of the tomb features rather than the vegetation features. So it's also in the GitHub repository under NIR tomb video tracking, so I can show you it running here. Okay, so that's our mask. Our mask is highlighting the value, that's the res, and that's the original. So the NDVI in this case is highlighting the region of interest around the tomb. Okay, so around the tomb it's appearing dark basically because we have a NDVI which is low. So the low values are being, because of bitwise NOT, the low values are being highlighted, whereas the high values are being depleted, if you like. So you can see it here as well. So the values of the video here, the blue values here are actually would be the higher values of NDVI, whereas the or near infrared reflectance, whereas the values that are now in red, kind of purple, pink colored, are actually the lower values. But because they're the lower, because it's bitwise NOT, the lower ones are being highlighted. They're the ones that are actually being highlighted more, and that's because you can see here the mask is operating as a bitwise NOT. Okay, so this is completely the opposite of what we would get if it was bitwise AND. So bitwise AND will give us essentially the opposite. So it'll show us that the background will be the higher region in terms of near infrared reflectance, and the tomb will be effectively ignored. So our mask is the same, our mask hasn't changed, but you can see here the tomb now is being negated effectively, and we're only focusing on our background, in this case the surrounding vegetation. So that would be a case if we were interested in doing NDVI to vegetation, we would use the bitwise AND, but for searching for the tombs, we want to use bitwise NOT. So that's effectively the programs that I've developed here in a nutshell. So these might come in handy for doing this in the future, and I hope to showcase more developments of this drone archaeology as I continue. And one development which I'm continually working on is a more robust type of feature detection in which I use the bitwise operation again, but in this time I do a bit more robust contour overlay, and also include a kind of a more robust detection of individual rocks, boulders, cairn stones in the actual tomb. And this has had limited success. The success it's had is primarily in the fact that it's able to overlay essentially boxes on the image. However, it sometimes comes out in a way kind of chaotic. There isn't really, unlike the feature here where it's relatively clean, the feature that comes out on the version 4 here actually is a bit messy. It ends up looking kind of a bit too information rich, actually. Yes, it uses a random number generator, so it generates a random number between 0 and 256 in order to basically overlay a contour, a color, a contour of a particular color on a box, a rectangle of a particular color. So let me show you it working there now. But as I said, the problem with this version is it tends to be too much. It tends to provide too much information overlaid on every single particular cairn, rock, boulder in the arrangement of these cairns. They're not. The reason being is that they're not actually perfect circles. The program identifies each cairn as its own individual circle, whereas I'd much prefer if it was able to identify the entire cairn as just one single circle. But that's the problem. I'm using contour detection rather than perfect circle detection. If it was detecting things like coins or perfectly round or even near perfectly round objects, would be a different story. But because it's detecting cairns which are not perfectly circular, not even close, they're more oblong shaped. So it ends up being kind of overkill in terms of feature detection. But in terms of probably there is a place for it in terms of maybe more sophisticated feature detection or counting, for instance, counting up the number of boulders or individual cairns, rock cairns in a image like this. But this still requires a lot of ironing out, and to be honest, I still prefer. I just did this as a kind of a finishing touch to what I had already started with, the general contours. The simple contours, I think, work better in many ways. Like if I show you in comparison the original Tomb Hunter code here, I find that there's nothing wrong with having less information in an image. Sometimes with these images, less is really more in terms of what you can get out of it. So here I have the image here with the individual. You can maybe even count up the individual rocks that make up the cairn by the centroids in these contour overlays. So yeah, I personally think that the version 2 is better gives a much cleaner set of contours. And if this is made transparent, it could be perhaps overlaid on the main image as well. So all of this is a work in progress, but I thought it would be nice to share here since I'd shared so many other things already. Okay, that's all I have for now of this project, so I hope to actually update it again in the future, and other image processing projects as well involving drones and archaeology. Okay, thanks for listening.